Okay, so I'm going to work the additional problems from section 14.4. This is for fall 2020 that were not included in spring 2020. So these are from the final review for fall. 22 through 26 are the new ones. 27, 28, and 29 in this review were actually done during spring. Those are the same problems. So just look back to the spring 2020 review videos and look up problems 22, 23, and 24. Okay. So anyway, just more problems to work through, right? So let's come over here. We've got a shop we can sell 50. So that is a demand at a price of 20. Okay. We drop the price by $1.50. So that means that we've got 20 minus 150. So at a price of $18.50, our market research shows we sell 3 more. So that's 53. So we get a quantity, a demand of 53 at a price of $18.50. Now what I'd like to do is it's easiest to set up, okay, we got to set up this linear function for the unit price P of the t-shirts sold daily as a function of Q, demand, the number of shirts can be sold. So Q is our input, a function of, that's our input, P is our output. So that means we've got, again, we usually think of points as X and Y. X is the input, so we're going to do Q comma P to directly get it. So what do we end up with? Well, let's see, we've got 2 points, Q comma P. So we've got 1 point is 50, 20, and the other point is 53, 1850. Okay, and we're assuming this is linear. So we've got y equals mx plus b from memory, right? So let's change this. What is our x? Our x is q, so that's going to be mq plus b, and the y is our p. So just for the variables we find, we've got to define them in terms of what we're comfortable with. Let me make some room here. Get rid of these guys. Okay. So we're going to make this linear equation. So slope here is going to be y2 minus y1, right? So actually I'm going to do this with my the ancient Indian, from ancient India. I'm going to just line up the points. Actually, I guess I could just do it over here. I got them, right? I just need to subtract 1 point from the other. So 50 minus 3. So I'm going to, since I'm going that way, I get a negative 3. 18 minus 1850. So that's $1.50 more, and it's positive because of the way I'm doing the subtraction. I take the input, put it underneath the output, so I get a negative 3. So my slope is 1.5 over negative 3. Let's go ahead and divided by 3. Let's see, is that going to be that's a pretty nice, yeah, it's 1/2. Okay, so now I get so deep into thinking, it should have just popped out. But anyway, our slope here, let's go back over here. There we go. I got the pen working again. Our slope is going to be negative 0.5. So we're going down. So as we reduce it by 50 cents, we'll sell 1 more because it's linear. Okay, and what's our y-intercept? Well, we plug in all the points, right? Or one of the points. Let's go with 50 and 20. We use our slope, so we get P equals minus 0.5 times Q plus B. Plug in the 0.50, 20. 50 is our Q, negative 0.5 times 50 plus B. P is going to be 20. Negative 0.5 times 50 gives us a negative 25. Add 25 to both sides. And that says that B equals 45. So for this A part, what we're looking for is we're going to get P equals negative 0.5, or 1/2 if you want, Q plus 45. It means if we dropped it to $0, we'd only sell 45. Interesting. I'll box that in. Okay. So we're on track here. So now we're going to do something else. We're going to say, hey, we got some surplus shirts or something. We're now, instead of selling for $18.50, we're going to drop it to $15. We're going to sell more shirts. We're selling them at a lower price. So what that's doing is using this demand equation. What we should be doing is we have this demand for 53. That's sort of what we want to sell. So what we're doing is we're putting this surplus into our consumer's pocket. Okay, and this actually should have been a little zero down here. So they give us the formula, D of Q. So that's what we have here at a price P, which is 15. The thing we need to calculate is our Q bar. What's our demand actually going to be at $15? So we do that first. So we're going to plug in 15 for P, solve this for Q. That gives us our integral here. But let's just go ahead and set up the integral. The integral will be the function we've got, the demand function. So it's going to be minus 0.5 Q plus 45 minus 15, right? That's where that 15 is. So we've just dq. And again, we've got our limits. We know we always go from 0. So now we've got to find out, what is this number here? We take 15 equals minus 0.5 Q plus 45. Solve it for Q. So we're going to subtract 45. Gives us 30. Negative 30 equals negative 0.5 Q. Divide both sides by negative 0.5 Q, which is a half, which is like multiplying by 2, right? So it's like multiplying by 2, negative is positive. We're going to get 60 for our Q. So we go from 0 to 60. This is our function. Might as well clean it up a little bit. So we're going from 0 to 60 minus 0.5 Q, and this is plus 30. And my suggestion is we'll get a nice decimal answer on this one. So let's graph this. Our y equals, we'll put in the function minus 0.5 x plus 30. There's our function. We're going to go from 0 to 60, so that helps us with our window. We want our x's to go from 0. I like to do a little extra, so negative 2 to let's go to 65. A little bit extra room there. Our y values, well, we're starting at 30 and we're going down. So y max at 40, that should include everything going down to 0. And then we'll graph it. And remember, it's going to be this is our surplus triangle up here. So from 0 to 60, let's go second calc. Number 7 is what we do. We integrate with this tool. And again, while it's very valid to learn how to do these all by hand, this is preparation for the final. And so this is how I would do it. And in business schools, I was in financial planning for 13 years. So 900. 900 is our surplus. Let me, there's my pointer. Let's see if I can get this. A consumer surplus, right? But you always want to check your work at least with the calculator, and on these sorts of things, doing it the first time is very much encouraged. In fact, even in engineering, I worked with an engineer, and he told us that the same thing. They don't want to see your hand calculations. They want to see that it's been run through a computer. And then they want to see how you put they know where the errors are usually going to happen is in the human element. So what we put in, once we get to the machines, those have been engineered, designed to do exactly what we tell them to. They don't make the errors. We're the ones that make the errors of how we put it in. Okay. So anyway, that's our consumer surplus. So with our surplus, the only thing, if this was if it's just a question in the fill in the blank or something, we're done. Just fill this in. If it's a free response, the one additional thing, again, you could work this out by hand. I want to see your work, or you can draw this and just label, 0 to 60. This is the area is 900. Okay. You could even see this little, so you're just reproducing integral of f of x equals 900. You show me you used a technology tool, and you were able to get it that way. So just let me know how you calculated this. Thanks.